In this video, we're going to go through and demonstrate how to use a lens calculator tool. Now for this demonstration, we've selected the Theia Technologies website. They have a very interesting and highly functional lens calculator tool. Now Theia makes lenses themselves, but the tool allows you to select other lens, and this allows you to use this tool for various manufacturers of lenses. So let's go ahead and give a background and go through some concrete examples just to get a sense of how the tool can be used. So I want you to focus on the diagram here at the bottom. What I've drawn out here is the placement of our camera. This is a bird's eye view, so we're looking from up above and directly downwards, and the camera is located at 40 feet away from the parking lot that I've drawn here, and it's 50 feet wide. So our objective in this scenario is to be able to size a lens's focal length in order to capture the parking lot within our field of view. So we know exactly how far away our camera is going to be placed from the parking lot. We know the dimensions of the parking lot. What we don't know is the type of lens we will need, or what focal length lens we are going to need. So this could represent a light pole here where there's some available power, and it meets our requirements for mounting a camera to that pole. So let's take what we know of the environment that we're dealing with, plug them into our lens calculator, and determine what lens focal length we will need. So as I said before, the resolution, it doesn't really matter in this case because we are looking at actually just capturing the parking lot. We're not interested right now in knowing what the resolution is going to be at various points within that shot. So we'll just leave that to whatever resolution for now. And then we would have to put in our sensor size. So let's go with a common format, which is 1/3 of an inch. And then, as we said before, we have another parameter that we know that we are 40 feet away, so we'll just click in here 40 feet distance to object, and then now we will adjust our lens focal length until our horizontal field of view equals 50 feet. So I'm just going to click on this slider and I'll move it up and down, and notice as I move it up, it's changing the focal length, or zooming in right now. If I move it down, we're zooming out, and our horizontal field of view is changing, and we need to get that to 50 feet wide horizontal field of view. So I'll just keep clicking downwards, and there we go. At 4 millimeters from 40 feet away, we're able to see 50 feet, a 50-foot horizontal field of view. So once again, let's quickly look at what we did know. We knew we were dealing with a 1/3 inch imager, and we plugged that in, and we knew we were going to be 40 feet away, so we plugged that in, and then we adjusted our focal length until our horizontal field of view gave us 50 feet, and that was enough of a horizontal field of view at 40 feet away to capture the entire width of our parking lot. So our field of view came out to 4.0 millimeter, and that was our focal length that we require. So we've used the tool to find an appropriate lens for our application, knowing the format or size of the CCD or CMOS sensor, the distance from the parking lot, and the size or horizontal dimensions of the parking lot. So let's go through and do another example. In this scenario, let's imagine we have a 100-foot wide parking lot that we wish to monitor, and we know our sensor size is 1/3 of an inch, and we've also got a lens that's 4 millimeters. So these are our knowns. So what we're trying to determine is how far away we need to place the camera from the area we wish to monitor in order to get the 100-foot field of view. So this is a less common application of the tool where you already have a lens of a given focal length, but this is just to demonstrate some concepts and basic usage of the tool. So let's go ahead to our calculator tool, and we said we were dealing with a 1/3 inch sensor size, and we know our focal length, or we've already have a lens in mind of 4 millimeter focal length, and we are looking to determine we're looking to monitor a 100-foot field of view parking lot, and we need to know basically how far to place the camera. And you'll notice after I plugged in those values, it's now showing as an output of 80 feet for object distance. So that was fairly simple. Let's go ahead and review this real quickly. So we knew our known values were the sensor size, the lens's focal length, and the field of view that we wanted to cover. And so we were looking to find out how far from the parking lot should we place our camera, and that distance came out to 80 feet. So for our final example, we're going to be looking at a zoomed in or very tight shot. So our known parameters are a 1/4 inch imaging sensor, but the focal length is unknown. Here is our camera placement of 500 feet away from say this is a parking lot here, and this box here represents an area of the parking lot. It could be a security sensitive area or some other high value asset location. Now our parking lot itself is 200 feet wide here, but this dimension is not of interest here. All we're concerned about is zooming in very tightly and grabbing the 50-foot horizontal field of view of the object we wish to monitor. So let's go ahead and plug in our known values and see what focal length lens is going to be required for this application. So we're going to change our sensor size to a 1/4 inch, and the value we're looking for is the focal length, so we don't know that. We know the distance to our object is 500 feet, and we know the horizontal field of view we want is 50 foot wide horizontal field of view. But we can't change that, so we're going to have to manipulate our focal length until our horizontal field of view shows 50 feet. So it's at 176, and we're moving upwards. We're zooming in tighter, and you can see the image or the picture actually changing to reflect a zooming in effect. And we're getting closer to 50 feet. And okay, we finally arrived at 50 feet, and the lens that we're required to use is 36 millimeters. So let's go ahead and take a look at our diagram and go ahead and plug in our focal length here, 36 millimeters. So the situation, we knew the 1/4 inch imager or the sensor size. We knew how far away we were from the area of interest. We knew the horizontal dimension of the area that we wish to monitor was 50 feet. We plugged those in, and it gave us a 36 millimeter focal length for our application.